Hello student, we are discussing the chemical bonding and the last class I discussed the resonating structure, bond order and correlations with the bond length. Now I am going to discuss very important topic, nothing but a Fajan's rule. What is Fajan's rule? Let us focus on Fajan's rule. Fajan's rule, because in the p block element this rule will be employed to describe the anomalous behavior of a different types of compound. What is Fajan's rule? The Fajan's rule, there are three rules there. The rule number 1, this is a rule 1, is nothing but a polarization power of cation. Polarizations power of cation. Polarization power of cation. Essentially, Fajan's rule used to give idea covalent character in an ionic compound. Covalent character in ionic compound. In ionic compound. So, Fajan's rule essentially will give you idea how you can explain covalent character in a ionic compound. There are three rules there. The rule 1 is a polarization power of cation. So, now when there is a one cation will be there and when there is a one anion will be there, then what will happen, my dear, you know, cation, it will take the electron density from the anion towards itself because anion already has extra electron. So, this is a cation and this is a anion, and then from the anion cation will take the electron density from the anion towards itself. This phenomena is called as a polarizations. This is called as a polarizations. And now I am introducing one thing, is called as a charge density. Charge density is related to charge by size. Charge by size. Charge by size. When the charge is fixed or constant, in that case charge density inversely proportional to size. So that means if size is more, charge density will be less, and if the size is more, charge density will be what? Less, and if the size is less, charge density will be what? More. Charge density will be more. Charge density will be more. If the charge density of cation is more, if charge density of cation, if the charge density of cation is more, polarization power of cation will be more. Polarization power will be what? More. If the polarization power is more, easily it will take the electron density from the anion towards itself, then sharing of electron will be more. Sharing of electron, that one will be more, then covalent character will be more. Covalent character will be more. What logic I am telling, one by one you understand. If that the charge density for it, when the charge is a fixed or constant, charge density is inversely proportional to size. When the size will be more, charge density will be less. When the size is less, charge density will be more. So that is why if the charge density of cation is more, then the polarization power of that cation will be more. When the polarization power will be more, it will take the electron density from the anion towards itself. Then what will happen? Sharing of electron between the cation and anion will be more. As the sharing will increase, covalent character will increase because the covalent bond is formed by sharing of electron. You got my point? Ionic compound is formed by complete transfer of electron. So, because of sharing is increasing, then the percentage of covalent character will increase. So, like that, depending on the Fajan's first rule, this is nothing but a Fajan's first rule. They will give the questions like this. Already you know, they will give like this: lithium fluoride, and then they will give you NaF, then they will give you potassium fluoride, then they will give you rubidium fluoride. They will ask you what is the covalent character order. What is the covalent character order? You look at the lithium, the size order will be what? Down the group. Number of cell will increase. As the number of cell will increase, size will increase. So that is why size order will be lithium is lithium will be lesser than sodium, sodium will be lesser than potassium, is lesser than rubidium. As the lithium will be the smallest size, charge density of the lithium ion will be the maximum. This is nothing but ion size order you can give like this. As the lithium ion has the least size, charge density will be maximum, polarization power will be maximum, sharing of electron in lithium fluoride will be maximum, and then covalent character of lithium fluoride will be maximum. Then the covalent character order will be what, my dear? Lithium fluoride is greater than sodium fluoride is greater than potassium fluoride is greater than rubidium fluoride. This will be the covalent character order. So then, because of that reason, the lithium fluoride is considered as a covalent. Lithium fluoride is considered as a covalent, where all these three is considered as a ionic. So these are the things you have to understand. This is based on Fajan's first rule. I hope it is clear to everyone, my dear student. I hope it is clear to everyone. Okay. Then come for the next rule. The next rule is nothing but a rule to polarizability or the size of the anion. Polarizability or the size of the anion. Let us focus for the next rule, polarizability or size of the anion. Let us focus that one. Rule 2. In rule 2, what the Fajan is telling, polarizability which is related to size of anion, related to size of anion, my dear. So rule 2 is a polarizability which is related to size of anion. If the size of anion is more, polarizability will be more. Here what is happening? There one cation size is same, but the anion size will be different, like this. Anion size will be different. This is a cation and this side is anion. All three anion, all three cation. When the anion size will be big, then electron where is there in the anion outer cell, which will experience less force of attraction by the nucleus of the anion. In that conditions, cation easily take the electron density from the anion towards itself, and then sharing of electron will increase. As the sharing of electron increase, covalent character increase, my dear. What I am telling, when the size of anion will be big, then the outer electron of the anion will experience less force of attractions by the nucleus of the anion. In that conditions, the cation easily diffuse the electron from the anion towards itself. This phenomena is called as a polarizability of the anion. And then sharing of electron will increase, and then covalent character will increase. And then if I give the example, lithium chloride, cation will be same. Lithium fluoride, lithium chloride, and then lithium bromide, and then lithium iodide. I am asking covalent character order. All cases cation is the same, but the anion size is increasing. Fluorine, chlorine, bromine, iodine. The anion size order will be what? Fluorine, chlorine, bromine, iodine. This is the size order. As the iodine has a more bigger size, then the polarizability of I minus will be more, or you can take directly F minus, Cl minus, Br minus, I minus. As the I minus has a more polarizability, then the lithium ion easily diffuse the electron towards itself, easily take the electron from the I minus, then the sharing will be more, covalent character will be more. So that is why the covalent character order will be lithium iodide is greater than lithium bromide is greater than lithium chloride is greater than lithium fluoride. This order will be followed because of I minus has a more polarizability, that is nothing but a bigger size. So that is why the valence electron or the outer electron of the I minus will experience less force of attraction by the nucleus of the iodine. So that is why the lithium easily take that electron towards itself, then there is ionic compound sharing will start, then the covalent character will be more. That is why the covalent character order will be lithium iodide is greater than, lithium bromide is greater than, lithium chloride is greater than lithium chloride. This is nothing but a rule 2. Come for the rule 3. In the rule 3, what is happening? Let us focus for that one. In rule 3, pseudo inert gas configurations. Pseudo inert gas configurations. What is called as a pseudo inert gas configuration? Like N-1 D10 and NS0. This is called as a pseudo inert gas configuration. If any metal ion in valence electron is containing N-1 D10 NS0 electron, that is called as a pseudo inert gas configurations. You know the d orbital has a poor shielding. When the d electron is there, it has a poor shielding. Because of the poor shielding, it will be exposed, the valence electron or the nucleus will be more powerful. Nucleus will be more powerful. Nucleus of cation more powerful. More power for the polarizations. More power for the polarizations. And in that case, what will happen? In that case, it will take the electron from the anion towards itself more powerful way. Because of this, whenever the d electron is present, it has a poor shielding. It cannot able to cover the nucleus properly. When it not able to cover the nucleus properly, the nucleus will be more powerful. When the nucleus will be more powerful, it will attract the electron from the anion towards itself. Polarization power of that cation will be more. As the polarization power cation will be more, it can take the electron density from the anion towards itself. Then sharing of electron will be taking place. Covalent character will increase. Then the covalent character will increase. This is the idea. This is Fajan's rule 3. If I take the example, CuCl and NaCl, which one will be more ionic? Here the copper +1 state, sodium as well as +1. Copper structure is nothing but a 3D10 and then 4S0. 3D10 is nothing but a N-1 D10 and then this is NS0. This is nothing but a pseudo inert gas configuration. Because of these pseudo inert gas configurations, the copper ion nucleus is more powerful, which will take the electron density from the chloride towards itself. Then the sharing will be more, covalent character will be more. Covalent character will be more, as because of copper nucleus will be more powerful because of poor shielding of d orbital, it will easily take the electron density from the chloride towards itself. So then polarization power of copper plus ion will be more, sharing of electron will be more, covalent character will be more. That is why the CuCl will be more covalent compared to NaCl. NaCl will be ionic in nature. So these are the 3 rules what I explain over here. One is nothing but the Fajan's rule 1, Fajan's rule 2, and one is nothing but the Fajan's rule 3. The rule 1 is nothing but a polarization power of cation. Second one is nothing but a polarizability. Third one is nothing but a pseudo inert gas configurations. So in this case, once you understand this Fajan's rule, then in the periodic classifications and as well as when you will go for the P block element, whatever the like questions like BF3, already we discussed. BF3 is covalent in the group 13 element, whereas AlCl3 is ionic in nature. How we will explain this phenomena? AlCl3 or AF3, same element we are taking. AlF3 is ionic. Both the cases, anion is same, but the cation is different. Here there will be boron +3 charge and then this will be +3. Charge also same. When the charge is fixed, then the charge density will depend on the size. As because of boron has a smaller size, charge density will be very high. When the charge density will be high, then what will happen? The cation has a more polarization power. It will take the electron density from the fluoride towards itself. That is why in case of a BF3, B+3 has a more polarization power, and because of that it will take the electron density from the fluorine towards itself. Then the sharing will be there. As because of sharing is increases, the compound will be covalent in nature. That is why compared to AlF3, BF3 will be covalent in nature, my dear student, which can be explained by the Fajan's rule 1. So that is what I am giving you example, the different types of Fajan's rule explanations and the different types of example. I hope you understand, my dear student. Please go through it, and the next class I am going to discuss is nothing but the dipole moment in detail. Then we will go for the Lewis-Dawes structure. What is the failure? Then we will connect for the valence bond theory. Then we will connect from the hybridizations. Then we will connect from the molecular orbital theory. These are the way we will proceed for the chemical bonding chapters, and I hope you understand and enjoy it. And thank you very much, my dear student. Thank you all.